Algebraic patterns, example 2, a quadratic pattern problem. So we have these shapes made out of matchsticks. We're asked to find an algebraic expression for the number of matchsticks needed for each pattern, and then for the number of matchsticks needed for the 10th pattern. We'll have to do a little bit of counting at the start because we want to work out the value for each term and what the first and second difference is. So let's consider the first stage in a pattern. So the first stage here, we can see a little box shape. So the number of matches to make that shape would be 4. There's 4 sides to it. With the second shape, look, we could count the whole thing from the start. I'm going to count the extra though. So the extra that we need to add on from the first shape is going to be a 6 more. So 6 and 4 is 10. So the first difference is 6 here as well. If we look at the next shape, building up from the first, so we don't have to recount, the extra matches required for this shape is an extra 8. So we have 10 and 8 is 18. And for the last shape, again, so we don't have to count the whole thing, we know there's 18 in this part, and the extra matches that we require here are an extra 10. So that brings 28 is the number of matchsticks for the fourth stage of the pattern. We're to work out the second difference, and we can see between 6 and 8 and 8 and 10, it's 2. So the second difference is constant. This tells us that we're dealing with a quadratic pattern here. We know its value is 2 as well. Quadratic patterns have the shape an squared plus bn plus c. What we need to do is work out the values for a, b, and c. We know that a is half the second difference. The second difference is 2. So half of 2 is 1. So the value of a is 1. That's the first bit solved. The next thing I'd like to do is work out the value of the 0 term if it existed. So we do some counting backwards. What would I add 2 to get 6? That would be 4. And then if I add 4 to something, I get 4, so that would be 0. So I could see by working backwards, the 0 term, even though it doesn't exist, but if it did exist, it would be 0. That would be the value of the expression if n equals 0. So c is equal to 0. Now we have one more parameter to get. We want to find what the value of b is. We've worked out already though that a is 1, so our expression so far will be 1n squared plus bn plus 0. So just neatening that up, so we have the term n is n squared plus bn. Now we know a few input-output values. We know when n is equal to 1, the output is 4, because the first term value is 4. So we could use this to work out what b is. So if I let n is equal to 1, so I have 1 squared plus 1 times b, that would be equal to 4. So 1 plus b is equal to 4, so b is equal to 3. And this is all the hard work done at this stage. So we know what our expression is now. We know that a is 1, b is 3, and c is 0. So we can write an expression for term n. We still want to work out what the 10th term is, but the expression for term n would be that term n is equal to n squared plus 3n. We can use this formula or expression to work out the matchsticks needed for the 10th pattern then, because term 10 will be, we replace n with 10, so it's 10 squared plus 3 times 10. That's 100 plus 30, so it's 130 matchsticks are required.